ಕೊಡಿ ಸರ್ ಸರ್ ಗೋಲೈವ್ ಕೊಡಿ ಅಲ್ಲಿವರೆಗೂ
ಅಲ್ಲಿ
ಅವ್ರು
ಮ್ಯೂಟ್ ಅಂತ ಮಾಡ್ಕೊಳ್ಳಿ.
ಮಾಡಿದ್ದೀನಿ
ಗೋಲೈವ್ ಆಗಿದೆ. ಇಲ್ಲಿ ಲಿಂಕ್ ಬರ್ತಲ್ಲ ಅದನ್ನ ಶೇರ್ ಮಾಡಿ ಅಷ್ಟೇ.
ಅದೇನೇ ಲಿಂಕ್ ಅನ್ಸುತ್ತಾ? ಅದೇ ಅಲ್ವಾ ಸರ್? ನೋಡಿ
ಅದೇ ಚೇಂಜ್ ಅದೇ ಅಲ್ಲ ಸರ್ FW
ಅದೇ ಇದು ನೋಡಿ
ನಾನು ಲೈವ್
ಇಲ್ಲ ಇದಾಕ್ಬಿಟ್ಟಿದ್ದಾರೆ TH ಅಂತ ಹಾಕ್ಬಿಟ್ಟಿದ್ದಾರೆ ಅದಕ್ಕೆ ಬಂದಿಲ್ಲ. ನೀವು ಹಾಕ್ಬೇಕು
ಸರ್ ಇನ್ನೊಂದು 2 ಮಿನಿಟ್ಸ್ ಲಾಗಿನ್ ಆಗಿ ಸರ್.
ಅದು ಹೆಚ್ಚಾಗ್ಬಿಟ್ಟಿದ್ದಾರೆ ಪಾಯಿಗೆ ಇನ್ನೂ ಸ್ವಲ್ಪ ಟೈಮ್
ಕಾಪಿ ಪೇಸ್ಟ್ ಮಾಡ್ಕೊಂಬಿಡಿ ಅಷ್ಟೇ.
ಇವಾಗ ಗ್ರೂಪ್ ಅಲ್ಲಿ ಹಾಕಿ ಇಮಿಡಿಯೇಟ್ ಟೆಲಿಗ್ರಾಮ್ ಗ್ರೂಪ್ ಅಲ್ಲಿ
ಫಸ್ಟ್ ಕನ್ಫರ್ಮ್ ಮಾಡ್ಕೊಳ್ಳಿ. ಓಪನ್
ಅಲ್ಲಿಗೆ ನಾನು ಯಾರು ಕಳಿಸ್ಬೇಕು?
ಇವ್ರಿಗೆ ಕಳಿಸಿಲ್ಲ, ನನಗೆ ಕಳಿಸಿ ಚೆಕ್ ಮಾಡ್ತೀನಿ. ಆಮೇಲೆ ಶೇರ್
ನಂಬರ್ ಕಳಿಸಿ ಶೇರ್ ಮಾಡಿ.
ಗ್ರೂಪ್ ಅಲ್ಲಿ ಮಾಡಿ ಸರ್.
ಹಾಗೆ ಒಂದು ನಿಮಿಷ ಲೇಟ್ ಆದ್ರೆ ಚೆಕ್ ಮಾಡ್ತಾರೆ.
ಎರಡು ಸಲ ಈಗ
ಲಿಂಕ್ ಬರ್ತಿದೆಯಾ ಏನಾದರೂ ಸರ್?
ನನಗೆ ಬಂದಿಲ್ಲ.
ಕಳಿಸಿ.
ಸರ್ ಫ್ಯಾಂಟಾಸ್ಟಿಕ್ ಬರ್ತದೆ, ವೇಟ್ ಫಾರ್ ದಟ್. ಕಾವ್ಯ
ಶೇರ್ ಮಾಡಿ.
ಈಗ ಆನ್ಲೈನ್ ಕಳಿಸಿ ಸರ್.
ನೀವು ಕಳಿಸಿರೋದೇ ಅಲ್ವಾ?
ಮ್ಯೂಟ್ ಆಗಿದೆ ಬಿಡಿ.
ಮ್ಯೂಟ್ ಆಗಿದೆ.
ಕಳಿಸ್ಕೊಡಕ್ಕೆ ಗ್ರೂಪ್ ಅಲ್ಲಿ ಕಳಿಸಪ್ಪ.
ಕಿಟ್ ಅನ್ನು ಸ್ಟಾರ್ಟ್ ಮಾಡಕ್ಕಿಲ್ಲ.
ಮಾಡಿ
ಎಲ್ಲ ಮ್ಯೂಟ್ ಇದೆ ಒಳ್ಳೆ
ಸರ್.
ಇಲ್ಲಿ ಬರ್ತದೆ ವಾಯ್ಸ್ ನನಗೆ.
ಅದಾದ ಫಸ್ಟ್ ಮ್ಯೂಟ್ ಮಾಡಕ್ಕೆ ಲೈವ್ ಮಾಡಿರೋದು. ಇಲ್ಲ ಮ್ಯೂಟ್ ಆಗಿಲ್ಲ. ಮ್ಯೂಟ್ ಆಗಿದೆ ಅಂತ ಬರ್ತಾ ಇದೆ. ಮುಂದೆ
ಇಲ್ಲ ಆವಾಜ್ ಮಾಡಿ
ಅದನ್ನ ಮ್ಯೂಟ್ ಮಾಡಿ.
ಹಲೋ ಆಯ್ತಾ?
Good morning, madam.
Kavyashree, can I start?
Yes ma'am, you can start.
Okay, shall we start then? Okay. Good morning, everyone. Hearty welcome to all the participants. On behalf of ATME College of Engineering, Computer Science and Department for this 3 days webinar on latest technology. It gives me an immense pleasure to host this event. I am Ms. Keertana, Assistant Professor from Department of CSE. I feel privileged to welcome all the professors of various esteemed institutions for this webinar. I also welcome all the enthusiastic student participants who have joined us today for this webinar. I welcome our beloved HOD, Dr. Puttegowda D. I also welcome all the internal faculty members of our college. It's a great honor to have with us today Dr. Gururaj KS, Associate Professor from Department of CSE, GSSITW Mysuru, who is going to deliver his talk on Introduction to Cloud Platforms. A very warm welcome to you, sir.
Thank you, ma'am.
I take this opportunity to read out the profile of Dr. Gururaj KS, sir. He has completed his PhD at VTU Belgavi. He has also pursued his MTech in Computer Science and Engineering from VTU as well. He has guided 25 UG project and technical seminar. He has also received a Mission 10X Certified High Impact Teaching Skills Award. He has also published various papers on national and international journals, and he has also attended various national and international conferences as well. Thank you for accepting our invitation for being part of this event, sir. I welcome you once again.
Thank you, ma'am.
I kindly I request all the participants to raise your queries in the comment section. At the end of the session, your queries will be answered. Thank you. Now I will give the control to you, sir. You can start the session.
Thank you. Good morning, all of you. Hello. Are you able to hear me?
Yes, sir, you can proceed.
Ma'am, are you able to hear me?
Yes, sir, you're audible.
Yeah. Are you able to see the screen that I'm sharing?
Yes, sir.
Okay. So, good morning to everyone. And I first of all congratulate the team of Computer Science Department, HOD, Putegado sir, and the coordinators for organizing this 3-day webinar. And I thank CSE Department of ATME College for considering me for as a resource person for this webinar. So to start with, I welcome all the participants of this webinar. So this webinar that I'm talking about today is about introduction to the cloud computing platforms. And this webinar basically focuses on providing an insight into the different platforms. And before going with the insight into the different cloud computing platforms, I'll be just focusing on the need of cloud and why we need these cloud computing platforms and how this is useful for us in our day-to-day life. And later on, I'll move on to two basic cloud computing platforms. One is AWS and the other one is Google Cloud. And there are many more cloud computing platforms, but I'll be focusing on these two. And I'll be just addressing about how to make use of this and what are the different services that we have over there. So to start with the agenda, as I told, we'll have a brief introduction and why do we need this cloud computing platforms, all this. Then we'll be discussing about the characteristic features of cloud environments. We discuss about the cloud reference model, the deployment models. And as I told, the different services are provided by the cloud. And we'll be discussing about there are various services provided. We'll be discussing in brief about some of them. Then as a case study, I'll be dealing with two cloud computing platforms, that is Amazon Web Services and the Google Cloud. So to start with, all of us are very familiar that we are all into internet. We are all, today's webinar is also based on internet and based on virtual environment. All of you feel that I am over there and I feel that all of you are over here and you're listening to me, and it's all a virtual environment that we are living in, right? So before the internet was available to us, there were various scenarios. If I want to set up an environment, set up a particular business, so you need to have a set of stores that you have to generate. You have to attract the advertisements for the public, and advertisement costs and the maintenance costs, your current bills, everything used to be more. And the cost of entry, if I want to start a business, the initial investment was very huge before we had internet as one of the parameters. So once we had the internet into existence, so we have without any real estate outfront stores, we can have various business started. We don't have need of any fixtures. All of you are using Flipkart, Amazon, and whatnot. But everything they are able to sell to you people or sell to us without any fixtures. They don't have any stores or something. They just deal with the persons who are selling the products and they are giving it to us. They don't have any upfront stores or anything as such, and they don't have any maintenance costs. Only thing that requires that they need to invest on advertisements, and they need to invest on the internet services, and they need to communicate with each other. They just act as an interface between us using the internet. And whenever I want to start any business with after the internet has come, the cost of entry, the initial investment, what we come across for starting a business has dropped down to a larger extent. And once we have this, the internet is changed complete aspect of how we carry out the business. But is internet sufficient? Or is it that if I have the internet, it is sufficient that I can carry out the business? So there will be a lot of drawbacks with starting the business with this, because if suppose let us assume that I want to start with a business, I need to invest for the infrastructure and all those things. But suppose let us say I started the particular business with a small infrastructure. As the days pass by, I need the infrastructure to be upgraded, and the old aspects becomes useless. So I have to throw that, and I have to restart with the things. So I may require a particular aspect for a certain duration of time, which I need not purchase, but I want it for certain duration of time. Let us assume that I have 200 GB of hard disk with me. But at a point of time for working with the particular project, I need 500 GB, but my laptop or my computer doesn't support it. So do you have any other environment where I can share that another remaining 300 GB of memory, use it for a particular point of time, and then once I'm used with it, I can just like it's like renting a car. I don't have a car, but I want to use a car, so I can go for Ola or Uber or anything. I can use it for a particular point of time, and then once I'm done with it, I can pay for it and then just stop over there, right? So that's how when I want an additional infrastructure, I need not invest it for it. So in such scenarios, what came into existence is what we call as a cloud environment. So before we entered into the cloud, you want to start an enterprise, you need to have an IT shops, you need to have a hardwares for internet service providers, you need to have softwares, powers, administrative cost, and again, the initial investment was very high. So once we have this computing resources, all that you want the computing resource, I have, as I said, I need 300 GB or 500 GB of additional resources, which I need not purchase it, but I can rent it from someone. That is what we call as a virtual environment that we are using. So you can use whatever the data that you want. You can carry out the processing. Suppose I have Core i3 processor, but that is not sufficient for me to work with that. So I need a processor with a higher end, but I'm not ready to invest on that for a longer duration. So I can use it for my particular requirement at that point of time, use it and then pay for what I use and then rent it back. So that is how the cloud environment has made life. So that is one of the major changes that has happened after the internet has come across. Along with the internet, the cloud has made a drastic change that along with the internet, cloud computing has made life easy, and our cost of investment, initial cost of entry, everything has been minimized. And that is what the power of cloud computing environment is all about. And how do we work with that? So what we need to do with this cloud environment, whenever we need any additional infrastructures, we need not bother about it. We can just use it as per our requirements, and then when it's not required, we can just share it. So it is one of the important things. So all of us are very familiar that on a day-to-day basis, we are using WhatsApp, we are using Facebook, many applications we are using on a day-to-day basis. But if we are into this, any of these applications, if we are using, just remember that we are all into the clouds. We are all using cloud on a day-to-day basis. If you say, if I'm using Samsung mobile, I have a Samsung mobile cloud. If I want my contacts, if I change my mobile, I need bother about saving this contact, storing it to the secondary memory, again restoring, but I store it in a cloud, Samsung cloud or any other cloud, I can retrieve it back. I can have my Gmail contacts, everything onto the cloud. Whenever I shift to some other computer, I can access it. So whenever, the main advantage of going with the cloud is that your data need not be at one place. It can be anywhere. You can access it anywhere. You can use it anywhere. You can. All of us have used Google Drive. Whenever we want to share anything on our Gmail, 25 MB and above, you cannot be able to share. So what we do, we upload it to the drive, provide the link of the drive. So what is the drive? It's nothing but a cloud storage that you are using again for that is Google Cloud that we are using. So on a day-to-day basis, anything that we are doing, you are using your Google Cloud, any of the cloud environments we are using. So how did this cloud computing come into existence? So in the initial environments, we started with grid computing. Whenever we want to solve large problems, that is parallel computing came into existence, which is nothing but your grid computing. We used to do jobs on a parallel basis, and we used to share the work, and the processing was done faster. We used to have instead of having one processor, we used to have multiple processors and carry out the processing on a parallel basis and complete the work. The time constraint was very important, and the processors that we had. But in that circumstances, your infrastructure that was required was more. And then we went for utility computing, where utility computing is about metered sharing of resources. Just like as I told the example of your Ola cab or something. As I use it for a distance that I've used or the time period that I've used, I'll be paid for it, right? So just it's a computing resource you are using based on the usage of your resources, you used to pay for it. But again, it is the physical infrastructure that was used in this utility computing based on the requirements. We used to use those resources, and then we used to pay for it. Then came the software as a service. Software as a service is nothing but all our applications. As I told, any application that I want need not be installed again. Just as I'm using Microsoft Teams here, but I have not installed the Microsoft Teams over here, but I am using it as far as once it is done with, I'll not be using it. So as and when if I don't want it, I can uninstall it and I'm not use that for any other. So in 2001 and later on, the software as service came into existence. We'll be discussing whenever we talk of cloud, three parameters come into are most widely talked about. One is software as service, platform as service, and infrastructure as service. We'll be discussing about that. Then came the cloud computing, which is the next generation of internet computing, where all the resources here, as in the earlier stages, it was about applications, or it was about your processing or computing resources, and that was shared. But here, everything and anything can be shared in computing, cloud computing environments, which is an advantage for carrying out the business. Whenever you are carrying out the business using cloud computing environment, the initial cost of entry is minimized, because you need not invest more on your infrastructures or the resources that you need. What I need to invest is all about how the centric way of computing that we work. It refers to that you share the applications as services over the internet, or you can share your hardware and the system softwares, or your any of the resources, the data centers where you can store your data, which provide you the resources. Let us assume that I have a service which I have to, let us assume that I'm able to provide to you. But I need not be over there with you people to share the resources. I can play at one place, I can use that resource, I can share the resource. And by sharing these resources too, all are benefited. As an end user, you are benefited, you are using it as far as your requirement is for me. And there's an additional resource that I have, and hence I'm lending it to you people, and I'm getting from you as a commercial aspects. So both the service provider as well as the service user are environment. A cloud computing environment is nothing but sharing of all the resources, whatever it may be. Anything and everything as a resource can be utilized in current scenarios, where you can share your applications, your computing resources, storage resources, data, and everything. But now, where are these resources available? Whenever we talk of cloud, one thing that comes into my mind, where is this my data stored? Whenever I use Samsung Cloud or my any cloud environment to store my data, where is my data stored? Whether it is stored in my mobiles, or whether it is stored in Mumbai, or whether it is stored in any location, where is it stored? So it may be at any location. It is again a storage device. Don't think that it's virtual. It is a storage device, but it is stored at different, but not in your computer, on your mobile or somewhere. It is stored at a particular location. And remember, it's not that your data is stored at one location. It is stored at n different locations. And there are chances that you have redundant data, but it has a certain advantage of having redundant data on cloud computing environments. So we'll discuss about that, why we need this. But overall, as a scenario, cloud computing environment is nothing but an environment where you can share anything and everything as a resource. But the key component that we need for working with a cloud computing environment is nothing but your internet service and a web browser. You may have a computing web browser, but web browser is a component. It is everything service is provided to you in cloud computing environment as a browser-based environment. So what are the characteristics of this cloud computing environment? So rapid elasticity. That means you can go from 5 servers. Suppose I'm working with 5 servers at present. I feel that I need 50 servers. You need not purchase it. You can get it from some service provider, use it according to your requirements, and find you feel that 50 servers are not useful for me. Then I can just release your cost of investment can be, that is, you can expand your requirements as and whenever you require, and you can contract your requirements as and when it is not required. For that, you can deploy that on a data center way of Asian. I'll show you how the data centers are segregated, and in which locations we have the data centers for the different cloud service providers at the further part of my presentation. And it is location dependent resource sharing. So it is you work on virtual environment. Remember that it's not that you are working actually on the resource which is on your computing system. Instead, you are working on an environment or on a computing system or on a storage device which is remotely located, but you feel that you are using it for you on your system, and you are using it with you have that particular complete resource completely with you, but it is completely virtual in nature. Virtual in the sense they are existing, but for a time being, whenever you are using it, it will be available with you. After that, you will not be using that, and you can make that resource to be utilized 24/7, or you can make it work for a certain period of time. You can configure according to your requirements. That is one of the important aspects of cloud computing environments. They are location independent. You can work on any computing platforms anywhere where the resource is located in any part of the world. You can use that resource. If suppose I have a particular data center in Mumbai, and I want a particular resource which is not available in Mumbai. So instead of going to Mumbai, the same resource may be allocated to you from some other data center. And you feel that you are working with your own resource at your own end. So that is one important feature that we can experience with respect to the cloud computing environments. So the cloud computing environment, as I told, it is designed in such a way that you can have anything and everything as a service, which can be delivered to the end users on demand with different types of IT services. All these IT services are categorized into three categories. One is software as a service, platform as a service, and infrastructure as a service. If you see this reference model that we have here, software as a service, all end user applications, scientific applications for data analysis, office automation, your CRMs, content resource management, then social networking, all Facebook, Google Docs, and your Twitters, and everything, whatever applications that you are using, everything is provided to you as a software as a service. And platform as a service, you can have your virtual environments like Hadoop, Google App Engines, Aneka as a platform. Then you can have your VMware as a platform. So I want to work with Ubuntu as my operating system. But for time being, for any particular application, I want Ubuntu as an operating system. I need not install it again. I can go to a cloud environment, configure my environment by using Ubuntu as my virtual platform, and configure all your applications, see how the results are available for me. And after I use it, it's done and dusted. I can just leave that and come back to my test out your applications on those platforms, and you can access those aspects. Right? You can make your cloud environment or the application that is designed as a public. Like all of us are using your Google Store, App Store. It's a public cloud where you can access your any application can be downloaded. You have there are certain aspects where you can subscribe and get the data. Like if suppose I want to get a newspaper, online newspaper, so I need to subscribe for it, and it is available on the cloud. Based on the subscription that I have, I can download this paper, read that, and I need not purchase a newspaper over there. So any service that I need, I can subscribe for that, but it is public in nature, but you need to pay for certain resources by any person. And the other one is a private environment, which is restricted to a particular environment, just like I have a company cloud. I have an environment where all of us are using atme.in or gtriples.edu.in. So these are private environments where the data that I store, the information that I store over there are accessible only to our enterprise that we are using. Any data that I want, I need to have permission to access that. If I am a part of the company or a part of that institute, I can access the data based on the credentials that are given to me. So only the internal people of that environment I can analyze the data. Anything can be done with respect to those enterprise models. And hybrid is a mixture of both public and certain part of the components are made as public. Everyone, like our websites, gtriples or ATME websites that we have, anyone can access what it is required. That is public in nature. But we have an ERP of ATME College, which can be accessed by only the set of people who can access that college can access. That becomes a private. So it is a hybrid model of a public as well as the private and cloud environment that we have, and we can deploy and work on those. This is that we are whenever we were doing that, we use many applications that are on Google App Store to edit our images. So those are the applications that we download from the cloud and try to use those applications. We need not use it as we need not purchase them. We can use it as per our requirements. So in addition to all this, we have messaging services that we use, like WhatsApp messaging services. We have SMS service. We have various messaging applications. We use internal message services. We have where communication between the. Now, if suppose I have registered for Amazon Cloud, Amazon Cloud service provider needs to communicate me regarding billing environments, how much time I've used a particular resource. As I told, based on the utilization of my resources, I have to be billed, right? So Amazon Cloud service provider needs to communicate. So I have a messaging service between the cloud service provider and the user of the cloud environment. So there needs to be internal messaging services that we use, and data mining services where I can carry out the analysis of the data. I store it huge. Big data is tomorrow. There will be a discussion about big data. We have huge amount of data which I can deploy, which I cannot deploy on a laptop or a computing because of the restrictions of my storage. I store it on some other location, and I try to do the analysis of this data by using data mining environment. All of these things in generic put together, all these services that I use are provided by the cloud environment, computing environment. So what is that machine in a cloud? So here, as I told, we have processors as machines which can carry out various operations of, if I am presenting today, my PPT is being processed by the processor that is on my laptop, which is being utilized. So similarly, I have a processor which is not sufficient to carry out a particular project that I am carrying out. So I can deploy it on a cloud environment where we have virtual machines. They are not actually into my computing environment I am working with, but they are stored at some cloud service data centers. I can use those virtual machines on the clouds, and then we execute that. You can create the images of those. I can have any number of instances of those virtual machines, use them parallelly and compute and see how the applications are executed. You can start those virtual machines as and when you require. You can stop them. You can make it continuously working and see how the application. Now all of us have seen our websites are continuously in execution. I'm not stopping or executing it at any point of time. Suppose I don't want to use that, I want to stop that website of that is being used. I can stop it as and when it is executed on a particular virtual machine somewhere. And all of us are very good at is we have heard about Google GoDaddy servers and everything, right? So we deploy on them and leave it as it is. They will be continuously running. If I don't want, just I can stop them and uninstall from that particular. You can just take it back from that GoDaddy server. So the simplest way of getting these things is make it as virtual as possible. Instead of purchase that, use it, cost of investment, everything becomes complicated. So what I do is I take a virtual machine on which is provided by the cloud service provider, use it as far as I'm in requirement of it, then pay for whatever the time that I've used, whatever the resource that I have. Is one of the best service that is given to an end user over that. Similarly, storage, as I told, storage of data is big data. Once we are into this applications that we are using on today on day-to-day basis, a huge amount of data is generated. And whenever we are working with the data, a huge amount of data, working on a single computing environment becomes very difficult, and storing that on a single end, it's easy to analyze the data. So what they can do is they can go onto the cloud, store, rent a particular storage or store them. Now, if suppose once one of the data centers fails and all your data is lost, so it becomes very complex. So what we try to do is in storage, cloud storage, and when your data is stored at multiple places, your data is not stored on one disk. Instead, they are stored at multiple environments. There is a concept of RAID environments, RAID disks, which it's not a part of this presentation. It's another very vast topic to discuss about RAID disk storage environments, where we'll be storing the data at different places. Down, the rest of the system takes care of that, and your system doesn't go into halt. There will be never a single point of failure is one of the important goals of this storage as a service that is provided by the cloud environments. You can store it on any number of disks. Anywhere you want, you can just store the data. If one fails, you can get the data from the different back. That is what happens with us. We need backup, everything backup. We store, we have any redundant data, but once one day, if I want the data, I'll not be finding where I have stored it. And you have an environment, you can access your URL and just you can get the data back to you. So cloud storage is nothing but another hard drive on your computing system, but which is not actually on your computing system. It's stored at some other cloud environment or the cloud service provider who is providing to you. Similarly, the database is similar to what database that we use. There are data sets, like we have a relational database, schema-based logical schemas and everything. You can have a transactional database that you can utilize. Just the databases that we use, we can also use the resources of the databases that are available in the cloud. But the different types of schema that we use, because of the different huge amount of data that we have, the schemas that we are using on a day-to-day relational databases may vary when compared to the schemas that we are using in your cloud environments, which will be dealt in big data and the next topic that we've dealt in tomorrow's big data and all those aspects. There we have different schemas of processing of that big huge amount of data that are stored in the cloud. So you can use those databases for processing of the data. Similarly, there are apart from this machine as a service, storage as a service, data as a service, as I told, message queuing is another important part of the services that we'll be using, and Hadoop and MapReduce to analyzing, like big data analysis that we carry out. We can use thousands and thousands of supercomputers or the virtual machines, and you can process a huge amount of data on those parallel processors and carry out the analysis of those data And as I told, now business is not limited to a particular part of the world. It is spread over to different part of the world, and the magnitude of the data that we are generating is very large. So we can't store it on a single computing system or a single storage device. Hence, we need all these different services. And not only just storing the data, you have very approaches which can analyze your data and say, this product, if it is sold in this particular region, you get more profit over here. You can do all those analysis. That is what we call as big data analysis or data analytics that we work with. And when we have huge of single computing environment, we can work on different resources that we have on the cloud environment to use them and to carry out the analytics and implement them. So as I said, considering all these services, are these machines that we are using on are on the cloud? Yes, you can move anywhere. Your processor, the process that you are executing can be executed on your computing system, or it can be executed on a processor or a virtual machine which is stored at elsewhere. It may be the virtual machine may be available in a cloud data center which is in US, or it may be in Australia, or it may be Mumbai. Anywhere your process may be executed based on the resource that is provided to you on your request. Storage, whether my data is available only on my computing system? No, it is available elsewhere also. If you lose your data, you have where your data, because it is redundant, it is stored at any number of data centers based on the importance of the data that you have specified, and you can get back your data as and when you require. So whether you have the databases, yes, your databases are also available elsewhere. You can access your database anywhere and from any part of the world whenever you need them. And applications, yes, you can run your applications anywhere you want, not only in a computing system that you are working with. If suppose let's say that. Hello.
Yes, sir. Yes, sir.
Okay, fine. Then we'll continue with that. So whatever we have discussed till now is about the cloud computing environment, the services provided, and how this cloud environment.
Excuse me, sir. Sorry for the interruption.
Yeah, ma'am.
Yes, now the PPT is available. Yes, sir. Thank you.
Yeah. Yeah. Is it available? Okay, fine. So we can continue now with different platforms that there, as I told, there is n number of platforms available for utilizing these cloud services. We will be discussing about two, that is Amazon Web Services and the Google Cloud. So what actually is Amazon Web Service is a platform which provides you, as I told, different services which includes your infrastructure. It includes your messaging services. It includes your data services. And as I said that for working with all these environments, we need to have a web-based interface. So this Amazon Web Services uses SOAP and RESTful web interfaces for working with for providing all these services. And it uses a web console. I'll just be showing you the web console and the administrative part of it, and how do we use these resources. And everything resource that I've used on web service on Amazon Web Services are monitored. It is being billed on a day-to-day basis, on hourly basis, per second basis, on a monthly basis. So as and when you use that, you pay for it. So pay as you go. As you use that, you'll be paying for that particular. For the beginners, for the first 1 year, it will be completely free. And after 1 year, you will be charged for all the resources. But within that 1 year, you have certain limitations to use the resources that are provided by AWS. And once you are going beyond those resources, then you'll be charged for that. So it is, again, as I told, it is pay as you use it, and it is used. So to work on this, as I said, Amazon will provide all resources to you using a web interface, which uses your representational structures for as a web interface for providing all these services. So these are some of the services that are categorized by Amazon Web Services. It has a set of computing services for computational purpose. That is Amazon EC2, Amazon Elastic MapReduce. I said, when you have a huge amount of data for processing and analysis, you can go for MapReduce, Elastic Beanstalk, cloud indexing the data, then auto scaling. So you can scale your resources. But if I have less amount of processors and I have n number of processing units that I have rented, then if I'm not using it, I can just scale it up that I have and work by using auto scaling resource that we have. Then storage, Amazon S3, showing all this Amazon SimpleDB for database services. Whenever we have relational database to work with, we have relational database services. CloudFront for all the interfaces that we work with Amazon services, import and export whenever I want to convert or I want to share the resources, convert from one platform to the other platform services. And for communication, like internal communication also, we can work with that. And whenever I want to communicate with the external world, I can use the communication services. So there are a number of services that we have. We'll be discussing one after the other, and we'll see how it works out on a, I'll give a live demo of how a particular computing services can be used and how the storage service can be used. So computing services, as I told, it's a fundamental element for any computing system that we want to work with. Amazon EC2 is one which provides you the most of the computing services for whenever we want to have a web application to run on that, where your data and the number of processing is not that to that extent, then I can go for a basic EC2 as a computing resource that I can use. You can deploy, it allows you to deploy servers in the form of virtual machines and create n number of these instances of EC2. The computing resource is implemented in the form of mirror images, machine images. I'll be discussing about the machine images, how a specific image will be created. As and when I have a new instance of computing resource I need, it will be created as one of the machine images, and then it will be working upon. And you can have a pre-installed operating system. As I told, I have Windows operating system, I out my application on different platforms. Then I can use this predefined operating system. You can have Ubuntu, you can have Windows NT Server, you can have different operating systems. I'll show how to configure this. You can configure for the number of processors, you can configure for the storage, and you can configure for the operating system that you want to use. And based on that, you can work on that and configure for execution of your application on a cloud environment. You can provide, but whenever you want to use this, you are provided with the credentials to access those instances and configure and install your application over there. And as I said at the beginning, that whenever you are using Amazon Web Services, for first 1 year, it is free and you are limited with the resources. As and when we go ahead with using the resources, you'll be billed on a monthly basis or on a usage basis. Based on how you configure that, your billing will be done. So as I said, your all your computing environments will be implemented in the form of Amazon machine images. Goes on, the complexity of your application goes on increasing. You have to configure according to your requirements. So Amazon kernels will be configured. Then we have EC2 instances. You can create n number of templates and computing power. As and when you have more number of instances, you can have more parallel processing can be done. So you'll have virtual EC2 units will be generated, and based on the number of EC2 images that you have, the faster will be your processing. There's nothing but instead of having a real CPU at your location, you have a virtual processing unit, which as the number of processing units increase and the complexity of your application that you are executing increases, you may have more number of instances of the CPU required for you. And the computing units can be used as per your requirements, and you can compute according to the requirements. So this EC2 environment can be configured by using an internal IP address where I configure that, and it is accessed to you based on your credentials that is given to you. It will be allocating a particular credentials like IP address, where I am storing that. So as I told, your data centers are not located at one place. These data centers are located at n number of places. This virtual computing environment that I have received, that has been assigned, are configured based on the internal IP address that is given to you. And as and when I access it, the resource is provided to you from that particular data center. But if suppose, let us say, I want an EC2 computing environment which is not in Mumbai data center, I can get it from some other data center and use it. So whenever you require any data or any resource from you, it's available to you from either of the data centers that you can access. And whenever we have the this external and different data centers, suppose I am, let us assume that I configured my resources for the applications from Mumbai data center. But as I am using it, sometimes I may not receive, I may not have an instance, or I may not have a resource which is already shared by someone else. I don't have the resource at that particular data center where I am registered. So I can get it from the external data center where the IP address will be configured as EC2 and the Amazon. So 4 parts you have here: external IP address, then the compute server identification that we have here. Every computing service that is recognized by this EC2 represent the computing. Then this XXX is represented by 3 parts. One is external IP address, then the computing identification number, and which zone I have that instance deployed from. If it is from the Mumbai zone or in US zone or in again South Pacific zone. So where I have got this data. So similarly, you can use storage services like a collection of storage for storage of your information. The core part of storage, has I listed out many storage services, and one among them most widely used for basic applications is the Amazon S3 simple storage services, where your data is stored in the form of buckets, which are nothing but the virtual containers, which are the memory locations where you actually store the objects, and objects are nothing but the actual content that have to be stored. And all these data that you store or your accessing methods and the way of processing data and storing it over there, everything is done by using, as I told, representational state transfer interfaces, which is a part of Web2 interface that we use for communication. Organized at two levels, as I told, the buckets and objects. These are virtual containers to store the objects. Objects are nothing but your actual data that I store over there and access the data. You can manipulate the data as you can create your data and update your data. You can rename. But remember, once you are storing this as S3 buckets, you cannot rename those data objects. Once you have created that, it's renamed. But if at all I want to rename them and recreate the data, but this Amazon S3 is most of the times for data which is not frequently modified. So data will be there, but I can access it, I can use it as and when required, but it should not be modified more frequently, once in a while, once in a month or once in a year. If I want to modify, like what you call archive data, whenever I want to store them, I can use this simple storage service. But once you store them with a name, they are stored. You can just fetch them and process them according to your. But whenever I want to rename them, the only option that you have is you can just delete that and recreate those objects and store that again. That is one important feature. But as I told, S3, there are many other storage services that are available when I want to use frequently modified data. Then there are other services which we'll be discussing. So access control and security is concerned. You have access and control policy for Unix operating system, 777, XXX, and all those options that we have. Here also we have permission. We can grant the permission for the resources, whether it is execution permission or it may be modification service permissions, all permissions. You can read the data. So by using this access control policies of Amazon, you can set up to 100 different instances of it can be created, and you can give grant permission for all those 100 different users at a point of time. You can grant read permission, which can just read the data and read the data, where you can allow the data to be stored, and you can edit it or you can remove that options. Only normally the one who has developed that application will have this right permission. Read access allows grantee to read the ACP resources, all the access permissions. You can modify the access permissions, write access permission. You can update the full control, gives you all the permissions for accessing the data. So before we go with the Google Cloud, just let me interrupt for, I'll go to the live demonstration of this, how it works out. I think all of you are able to see my screen. Kirtana ma'am? Hello? Kirtana, are you able to see my
not
screen?
visible.
Hello?
Sir, it's not visible.
Actually, I have opened AWS this one login. Are you able to see that?
No, sir, your PPT.
So I'll stop sharing and I'll go
Yes,
to.
sir. Yes, sir. You have to do that. Stop the sharing and then.
Just a minute. I'll stop sharing and I'll go back to that.
Yes, sir. Yes, sir.
Yeah. I'll just. So I think you're able to see my screen. Kirtana ma'am?
Sir, no, it has not yet been shared. Just now it got.
Sir, it's now visible.
Yeah. Yes, sir, we can see.
Are you able to see the AWS this one?
Yes, sir. Yes, sir.
We can see it's
Okay, fine. So this is my AWS platform that I'm using. So these are the account ID, the username, and I have a password settings. So these are all my credentials and the billing information that I have. So whenever I want to use the services, so I can have n number of services that I can use. This is my billing for what I am using. So I have to pay 229 rupees based on the usage. So I have used EC2 service for almost $2.57. Data transfer charges are less because I am using my college service and I have not used any internet. So I have used the tax. So my basic utilization that I have done on last month, I have used $11.61. The July month, I have used 3.03. So this gives me, I have used only one particular resource over here. That is basically my EC2. So how do I configure this? So this is one EC2 that have one instance of it that I have created here, the instance ID. Then I have used instance type where it is available. I'll just launch one particular instance of EC2 and show you. So whenever I want to launch this EC2, all of you able to see the screen that I'm sharing?
Yes, sir. Yes, sir. It's visible.
Okay. So first, so there are 7 steps to go about. One is choose the Amazon machine image. So if you see here, you can see there are various types of operating system I have, what platform I am using. So I am creating an instance now. Earlier I had one instance of EC2 that is generated over there. I have platform Red Hat Enterprise, then Microsoft Windows Server, number of platforms available. Totally, I have to select I have nearly 40 AMIs that I can select, different provisions. So different versions of operating system that I have over here. So let us assume that I want to work with Linux, Red Hat Linux. So I'll select this. Okay, once I'm configured with that, I have to select the instance type. So instance type is nothing but what type of what purpose I'm using, what type of optimized, compute optimized processor I need, or I need, just a minute, storage optimized I need. So what type of family of resource? Just a minute.
Okay, sir. Okay.
So I have different types. General purpose, when I'm using web interface or something, I can use general purpose. If my optimization is to be
Okay, thank you, sir.
computation processing is more than the data and accessing, then I use this GPU where graphic processing is more. I can has to be minimized. Then I go for memory optimized, storage optimized. So I'll use a general here. I can select the type of a processor, number of CPUs I need, the RAM usage, the instance that I want to use, then low to moderate network performance that I'm using. So all this IPv6 is for networking purpose. Whenever I want to use IP protocols for communication, as I said, everything is service. I need to access them through IP. If I disable this, automatically I'll not be able to access them. Web application cannot be implemented without this IPv6. So I can select one among them. So I am free tier C because I am using free tier over here. So I cannot use any one among them because I have not paid any amount as of now for the billing payment. So I'm eligible for only one instance over here. That is the second instance. So I selected that second instance. So then I can go for the next, configure the instance details. So how many instances of EC2 I need, whether I need 2 instances or 3 instances, I can just change these instances. Then network features that I need, then the subnet configurations, all are available by default that I am using. Then capacity, whether I need to reserve. If it is open, then anyone can use this if I'm not using that particular resource. If I reserve it, no one can use it till I just give up this particular resource for myself. So I can reserve this as per requirements, but as a free user, I can't do those options. So shutdown behavior, run on a shared hardware instances. So whenever I'm using web applications, I need not stop it because it has to be continuously executed. I configure it on run on a shared hardware instances. So then once I'm done, I've selected first machine I have selected, then I have selected the number of instances. I'm configuring the number of instances. Then for my particular virtual environment that I'm going through, I need to add the storage. So I go for the storage. So what type of general purpose is 1 GB. If I want, I can increase that as per my requirements. And then you can add those volumes of data. So the speed at which, so delete termination, no, you cannot delete it without your permission. So that is what I'm trying to configure this. You can, and it is a root application storage. And I don't have any that I'm configuring here. I have only one drive that I configured and it is of 10 GB. That for my application that I required was only 10 GB. That's configured over here for demonstrate the tags as per my requirements. What is my the key terms that I want to install. If I want to have security aspects, so security provided to me, I'm using available security features required for this. So compute this, then go for review, and you can just launch that particular. So keeper has to be given, so you can give the keepers and configure this. This is how you configure one particular instance of an particular instance of your unit that we have come across. Similarly, there are n number of services like compute services. You have your services for blockchain, for analytics, you have business application. So end user workspaces you can go through. For Internet of Things you can work with. See, anything that I want to work, I was talking about S3. Amazon S3 is one storage, but you have to store the data for a longer duration, and it should not be frequently modified. If that is the case, I can go for a S3 Glaciers, where I can just store more frequently. I can go with this, or I can go with Amazon AWS backup. If I want to have it in the redundant locations, I can go for backup data. So for relational databases, I have a n number of services that are provided to me. Amazon DB, there are many. So if it takes many days, so based on our requirements, I can just go through one of the services and use that and work on that. So billing based on the, as I told here, billing environment based on my utilization. It's already 1 year is done with. So I've been charged for usage of this amount, whatever the resources that I'm using. Okay. Hope I can go back to the presentation. Hello.
Yes, sir.
Are you able to see the presentation now?
Yes, sir. Yes, sir.
Okay. So find AWS as a platform. Coming to the next platform that we have, that is Google Cloud. Again, same as I'm not going to that. So here all the services that we saw in Amazon Cloud are available here. Amazon Compute Engine, cloud storages, SDK for developing applications, BigQuery for database applications, Kubernetes applications that you can execute. So all whatever we have in AWS are also provided in Google Cloud. And again, the same features that we work. So here in Google Cloud, the compute engine, we have their EC2 and all those. Similarly, we have general purpose N2 machine for balance pricing and performance, which are suitable for most of the workloads at web applications, all those that we come across. Whenever we have more workloads for that, I go for N2D services for computing and memory. If computing and memory are my primary requirements, I can go for N2D virtual machines. When I want to work with total TCO, that is total cost of operations, then when we want to work with that, we can go for the lowest cost. If I want to invest total cost of operations, if I want to be very less, I can go for it. If I want to have a high-end CPU for more performance, it will be high, and I need not water the plants over there. In summer, I want to monitor the humidity over there. Based on if the humidity is very less, I need to water the plants, then I can configure it. So I can configure this. Are normally low cost, short term, which will be the live migration of virtual machines. You can migrate your virtual machines from one particular environment to the other particular environment without rebooting. I am working with Windows operating system at present. I can migrate it to another platform that I want to work with. I can go with that. So the persistent disk that I can work with, hard disk or SSD disk, or how do I create this new persistent disk? How do I add that? What is the capacity of that? Whether I need to access it continuously. So whether I can attach that whenever, just like as we do our USB, whenever I need it, I use it. Whenever I need not, I don't require it, I can remove that. So local SSDs that I can work with, compute engine for encrypted data block stores that we can store those encrypted data for IO operations. The latency, internal memories, wherever I want to work with faster access of the data, I can configure that for relatively less data latency. If I want faster access of the data, I can use it. GPU accelerators, whenever I'm working with more of image processing, more of processing of your data, graphics processing that I want to work with, I can go for GPU accelerators for going through that. Then I can go for load balancing for based on my requirements. I can access. I forgot to show you the different locations where the data will be stored. you have data at different locations. The Amazon services that I showed, it was Mumbai that I have selected as a data center, and it was selected. You have n number of data centers at different location. One in Singapore, one in India. We have only at present Mumbai as Amazon Web Services that we can use. And billing as per Google bills per second level, per hours, per month, billing can be done. And commitments. So based on the discount, certain, if you are a regular user, you may get discounts up to certain aspects, up to 57% based on how you are using that. If you are a regular user, your discounts will be more. If you are using an occasional basis, your discounts will be minimized. And you are a free user, you'll get up to, in Google Cloud, you'll get up to nearly $300 of services. You can use it for free for 1 year. Once, whichever is early, if you have used $300 of resources first, then you will be paid again later. Or if you are not used $300 of the resources and your 1 year period is over, 1 o'clock 1 year period is over, then you will be charged for that. So you will be using those resources according to the discounts provided to you. And as I told, reservations again, you can reserve based on your zone, whether I want the resource to be reserved over there. In Mumbai, I'm using one EC2 server, one server over here, and one computing engine is being used over here, and I want to use it at that location only continuously. Then I can reserve it. If not, I don't reserve it. That computing resource may be used by someone, and if it's not available, I can use a resource from other data centers available. I can just create those services. So if you see here, data processing, how the data processing is done in Google Cloud. So users, they create the data, and it's you select a compute engine, and based on the type of computing nodes that you have used, they will be segregated to the computing nodes with multiple instances of the virtual machines that you have configured. They create all this processing of the data. So once you have this multiple instances, it will be much faster, and the output will be created, and the instance will be stored in the permanent disk. So your input will be given by the user to this file system, which will be taken by the computing nodes on the virtual machines, generates those, and then the results of that processing are stored on the cloud storage, which can be accessed by you. There are various cloud storage, etc. You can access the data and carry out the analysis. If you have an analytical engine from the Google Cloud that you have, that analytical engine will take the data from this cloud storage, try to process that, and again give it back to you as an output to you. So here are the virtual images. So customer ANMS can be using a number of virtual. If it is a normal environment, virtual machine 1 is used by customer 1, customer 2 is using 2 virtual machines, customer 3 is using 1 virtual machine, and you have your host hardware. I'm using this. Now I'm presenting to you people from my system, which is communicated to you who are all spread over at different locations. So to act as an interface between the host resource and the virtual environments, we have an interface, what we call as a hypervisor, which takes care of all the coordination activities between the cloud and the host resource. I have one data which is provided from the host resource, which has to be communicated to the virtual machines at the Google Cloud environments. They are taken care by the hypervisor, which is nothing but similarly or what we have an operating system which controls every coordination activities and how the resource allocation has to be done, how the scheduling has to be done, which particular virtual machine to be used, how to configure that, the billing aspects. Every part of it is taken care by the hypervisor, which acts as an interface between the hardware, host hardware, and the a number of cloud resources that I am using. Similarly, when I am using a sole user, a single environment, it is shared resources here. When I am using a sole tenant resource, I have taken all these virtual machines for my requirement. I can use all the virtual machines as per my requirements and work on this environment. Similarly, I have a storage environment, as I told, retention, so different triggers for deletion, transition of your data. You can add. There are a number of provisions given for data storage, deletion, permissions, or updations, all those options as we saw in S3. And there are various provisions given in Google Cloud also. You have stored copies, where I store them, whether it has to be overwritten, from which particular data center I'm using that, and retention policies, how long it has to be retained, whether it is to be retained for a longer duration. Whenever I have archive data, I go for more retention periods. If data is for a temporary period, for only processing parts I need, retention periods can be minimized. Again, based on the retention period that of the data that I want to store on the cloud, your billing amount goes on varying. So where do I store them? the containers, again, the different types of containers for storing the data. How do I store them? Like encryption data, the cloud key management. I can use various cryptographic algorithms for securing my data. And whenever I want to interact with this cloud storage, how do I have my credentials managed? All those customer supplied encryption keys we can use. Bucket levels of data that you can work with. How do I access the control access, like editing, read, write permissions? All this can be generated. Okay. So the requests for all the services that I explained for AWS are almost same. You can go on exploring different aspects of this content storage aspects over here. So what actually is the issue now? We learned about cloud. We learned about two different of environments. So whenever we work with the internet, whatever the scenario may be, whenever we work with this cloud environments or internet as one of the resources, first and foremost thing that we think is it secure? All data, all the virtual processing that I do, I'm doing it not on my particular computing environment. I'm doing it at a remote location. And whether the data that I share, is it secured? Security is a very, very important aspect, which is debated on a day-to-day basis. And hence, most of the research work is going on the cloud security, because we want our data to be secured, our processing activities that we need to be confidential enough, right? So security is another important aspect that we need to work with. So whether we lose the control of our infrastructure, if I'm sharing my resource on the cloud, do I lose my data? When I need that particular resource, do I get it back whenever it is essential for me? Suppose let us assume that I have a car, I am giving it on a rental basis. So if I give it on a rental basis, do I get back the same car back with the same condition whenever I need it? So it's again an important aspect, whether if I am giving my resource for a cloud environment, when I share it to someone else, whether do I get back the resource as and when I require in the same condition as I use it? How reliable is the cloud environment is another big issue that we have to concentrate upon. And if I partner with someone using it, how trustworthy is that particular partner? If I'm using my data on Amazon Web Services, and all of us are familiar now, TikTok, everything is banned, but are we really that the data that we are sharing on TikTok or something, is it reliable? Whether they have been shared? No, still it's still an issue that we need to concentrate upon. So all are legitimate issues, but still we are bound to use it because we have been using and we have into the internet, we are into the cloud. Sorry. So again, when we come to cloud, the same issues that we had with the internet, same works. So what is that we need to do is, issues remain. We have got to work with all these issues. And when we need to work with all these issues, because we have more of economic benefits, your cost of initial cost of investment for carrying out a particular business is very less when we use cloud. There are many advantages when compared to these issues that we have. So we need to find a way to solve these issues and try to go about and use this cloud environment for the benefit of the individuals and for the best processing services that we can use, and we can work upon those things. And so with this, I think these are the references that I have worked with. That is cloud, Amazon, as I already went through that, Google Cloud, then IBM Developer Works are some of the references that were used, and Mastering Cloud Computing by Rajkumar. If you want to explore more of things, you can just go and explore this. As I showed for Amazon, I could just focus upon only EC2 as an instance of computing resource. There are n number of resources that you can explore and use it and work upon it and try to work and deploy your applications on different environments and see how your applications are effectively executed in those environments. You can configure according to your requirements and try to do various numbers of analysis of your data, or it may be computing resource that you are using, or it may be applications. If I want a particular application for my project, need not bother about it. You can go on to AWS or Google Cloud or onto Aneka web browser. You find your resources and you can use it. Now, a resource is not at all a problem for working. Only thing is we need to concentrate on how do I work. Resources are automatically available as a cloud service for us, and you can use those resources as and when it is required for you. And cost automatically, as I told, it is more economical when you use it because you will be using it as and when it is required for you. And hence the cost effectiveness is also very important, but still there are certain issues which we need to take care of it. Thank you for your patience listening, and hope I've addressed. As it was an introductory session, I focused a little bit more on the concepts. Then, because of time constraint, I think I could not go on to deeper about AWS. And thank you all of you for your patience listening. Thank you, ma'am.
Thank you so much, sir. It was very effective and useful for all the participants. Many of the participants here are students, so hope it will be very helpful for them if they are doing cloud computing projects. We had asked the students to raise queries in the comment section. We have given them the YouTube link.
Yeah.
So most of the students, they are requesting us to, share the PPT what you have used. So that is one thing.
Yeah, sure, ma'am. Sure.
And I'm requesting you to share so that I can forward them. And there is only one query from the faculty end.
Yeah.
And the question is, they are asking whether we can implement ANOVA statistical data, that is analysis of variance, whether that statistical data can be implemented on cloud to into cloud storages to implement any sort of mathematical models.
Yes, ma'am. We have mathematical models can be implemented. There are various platforms you can work on that. There is a statistical analysis tool itself in AWS. So you can use various. You can put your data into various storage devices, and tomorrow when we have this big data aspects, there more of statistical analysis will be done over there. So you have. Aneka is more than AWS. There is one more Google cloud platform called as Aneka. This is more suitable for mathematical analysis whenever you want to work. Yes, Amazon also provides you with mathematical statistical analysis, but more efficient, as far as I have observed, more efficient would be Aneka instead of for mathematical and statistical analysis you can use over there. But for application as a platform, and when you want to run web applications, or when you want to run any sort of your resources like mobile applications or anything, then the Google Cloud, and whenever you want to analyze a huge amount of data, then it becomes. But for a simple mathematical analysis, I don't think Amazon Web Services or Google will make much more sense. You can, I think Aneka would be better option to go about.
Okay, sir. Thank you. Then I think we have come to the end of today's session. I once again thank you on behalf of ATME fraternity for accepting our invitation and for being part of this.
Thank you.
Thank you so much, sir. I request our beloved HOD, Dr. Puttegoda, sir, to speak a few words.
Good afternoon to all. Good afternoon, sir. Dr.
Good afternoon, sir.
Actually, this COVID has made us to think in a different way, to deliver the skill set to the audience or the participants in a different way. And it has made us to interact with the participants in a different way. So in this direction, ATME College of Engineering and the Department of Computer Science Engineering is organizing these 3 days webinar on latest technology. Today's day one, today's resource person, Dr. Gururaj K.S., Professor in GSS College of Engineering, Mysuru, has delivered on the cloud platform. He has given an inside view of the cloud computing, and also given the demonstration of AWS also. So on behalf of the college and the department, I'm thankful to the resource person, Dr. Gururaj K.S. Thank you very much, sir.
Thank you, sir. Thank you.
Share the certificate virtually.
Share the certificate virtually also, but you know,
Probably it's not okay. General, I will share that one. Okay. Thank you very much, sir, for your the importance on the cloud computing. I hope all the participants will get this information and implement their project. And also thank all the participants from various institutions that supported in this webinar. So still 2 more days are there. Okay, the webinars on the different domains. So kindly I request you to attend this remaining 2 days webinar so that we will acquire the different knowledge. Thank you very much.
Thank you, sir.
Thank you so much, sir. Dear participants, tomorrow there is one more distinguished speaker who is going to join us. It is Dr. Andy Dharani, Professor and Director from RV College of Engineering. And the topic is about data to big data and decision making using machine learning. Please do join us tomorrow at 11 o'clock. We will share you the link again. Thank you everyone for your patience listening. And I once again thank our today's distinguished speaker, Dr. Gururaj KS sir, for joining us and for giving us a wonderful insight into the introduction to cloud platforms. Thank you again.
Thank you. Thanks a lot.
Thank you, sir. Thank you. I thank all the participants for your patience listening. Our feedback link will be shared to all of you. Kindly fill your feedback and please do join us tomorrow at 11 o'clock again. Thank you once again. Thank you, everyone.
I'll be disconnecting.
Yes, sir, you can. Thank you.
Okay, feedback.